Okay, so 8.4 today. 8.4 is usually a little easier than some of all those little piddly radical things. All right. So the rules for adding radicals, do I have everything going? I've got my Zoom recording. You can see it, they can see it. I think I'm good. When you add radicals, it's the same rules as whenever you add terms. They have to be like terms. Just a quick reminder, this is not a radical here, but it's going to be the same idea. So back when you're adding like terms like this, remember how you add the coefficient, but the variable does not change, right? We do not add x and x. So we add 2 plus 3, which is 5, but the variable stays the same. Remember that when you're adding? So different than multiplying. So same thing for number 2. This is the radicals have to be the same for them to be like terms, just like when we had to have an x for both. We have to have the same radical if we're allowed to add the coefficients. So we do the same thing here is we add the coefficients, which would be 2 plus 3, which is 5, but the radical does not change. So it's just 5 square root of 3. Okay. Not quite. Yeah.
So just what is that called?
This?
X is the
Well,
the exponent.
yeah. So so as you know, the index here is technically a 2 because it's a square root, right? So that's called the index. The 3 is called the radicand. And also the whole square root of 3 is the irrational part, because if you put that in your calculator, it goes on forever. It's a decimal, that decimal number goes on forever. And the 5 on the outside is the rational part. I don't know if that's what you were saying, but 5 is also just like, we can also just call it the coefficient.
Okay.
Just like, yeah. Oh, okay, then what's the reason? Yeah, it's just the coefficient.
Okay.
No, the 5. Well, yeah, up here, the 2 is a coefficient of this term. The 3 is the coefficient of this term. Once I put them together, the 5 is my coefficient. Yeah, it is the coefficient. Yeah, just like over here, like this is the coefficient of x. Remember how we always said that? It's the same thing. Okay. Okay, so number 3, what do you think the answer will be? That's not a power of 4, that's an index. No, remember, just like up here, like these don't change. So square root of 3, they don't change. Yeah, so that's called 4th root. Anything else here is the root. So 4th root of 10. Yeah, so we subtract the 5 minus 2 and get 3, but we don't change the radical. Don't ever try to change that. Here's one, I'm going to add another one real quick. Here's one people miss all the time. What do you think square root of 2 plus, no, let me change that. What do you think square root of 3 plus square root of 3 is? This is just an extra problem. No?
I don't know how to phrase it, but 2 square root 30.
Yes. So many people on that do say they answer square root of 6. They add the 3 and the 3. But remember, again, you add the coefficients. Technically, there's a 1 and a 1, right? So it's 2 square root of 3 is the answer to that. People miss that one all the time. Okay, so these are not like terms right now, right? Because what's in the radical isn't the same. But maybe we could get the radical to be the same if we simplify each one. So how can we simplify square root of 18x? Yeah, it's not a perfect square. 18 is not a perfect square. So do a prime factoring tree for 18. Okay. 6 breaks down to 3 times 2. Okay, so let's go back over here. So we have the 7 on the outside, and inside here we have, I'm going to put it in order, 2 times 3 times 3, and then we still have an x, right? I don't have enough room. Put it down here. Okay, everybody good with that? 2 times 3 times 3 times x plus 4, and we'll have to break the 50 down also, right? Okay, 5 times 10, and 10 breaks down to, okay, so we have 2 times 5 times 5 times x. That's from 8.1 to 8.3. So everybody good with that? All right, what can we do in the first radical? Yeah, it's a square root, right? So we're going to circle anything we see 2 of. And what about this x? How do we know if it can come out or not? We talked about this the other day. The power divided by index. Okay, so what's our index on this one? Okay, and so how many x's minimum do I have to divide some of them out? 2, right? So remember, if ever you have less x's here than what this index is, then they're going to stay in, right? Okay, so over here we can circle our 2 5s. Again, we only have 1 x and our index is a 2, so we can't take anything out. So out in front, we still have that 7, right? But we're also going to bring a 3 out to be with the 7. That gets multiplied. And what do we have left? 2. No, the 3's came out. 2x, yes. Yeah, remember from that we learned the other day, because what's 3 times 3? And what's the square root of 9? 3, that's what brings a 3 out. So remember, when you circle a group, you just take out the number that's representing that group. That's a group of 3s, so we just take out a 3. This is a group of 5, so we just take out a 5. But it goes with the 4, so 4 times 5 square root of 2x. Now what do you think? Yeah, 7 times 3, multiply the things in front. So 21 square root of 2x plus 20 square root of 2x. 41 what? Okay, yeah. So now they are like terms, right? Because we simplified. So if they're not, your goal is going to have to be to simplify both of those, which we learned the other day. So if you did your homework, that should be something you know how to do. Then once we have the same radical, we add our coefficients. So 21 plus 20 is 41, and our variable, or our radical does not change. Yeah. You don't necessarily, and sometimes like there's 3 of these, and I think if I remember right, one of these won't, but then it's just won't be a like term. So, yeah. Okay. All right. So, I'll walk around, go ahead and do a prime factoring tree off of each of these because none of these are perfect squares, right? Square root of 8, square root of 50, square root of 200. So do your tree and get them all into prime numbers, and then we'll go from there. Remember, you can start with anything. Like with 200, you could have started with 2 times 100. I started with 10 times 20, but you should always still get all the same prime numbers. Give enough time. So we have 3. And then did you get 2 times 2 times 2 for the 8? Okay. Minus 6. And in the 50, did you get 2 times 5 times 5? Plus 2 times, and for the 200, we got 3 2s and 2 5s, right? Did everybody get that? Okay. And again, if you like the 200, if you had broken it down to 100 times 2 and you know that the square root of 100 is 10, go for it. You know, you don't have to break it all the way down. Okay, how many are we going to circle? Groups of 2, because it's a square root. So we can circle 2 5s here, 2 2s and 2 5s, right? Anything we see group of 2 of. So out in front, we have the 3 and now times a 2, right? And what's left over inside? Yep, the 2. Minus, and here we have a 6 times, we're bringing out a 5, right? Square root of 2. Oh, this one is all going to be like terms. plus, we already had a 2. We're bringing out another 2 and a 5, right? All of those get multiplied. Square root of 2 left over. So then what do we get? And we, yeah, 6 square root of 2 minus 30 square root of 2 plus 20 square root of 2. So they all are like terms, so we can put them all together. What do you get? Square root of 2. Now, if this last one, for example, if this had been 20 square root of 3, then you could put these two together, but this one would just have to stay alone. And that does happen sometimes. So you can only combine the ones that have the same radical after you're done. If another one doesn't, it stays separate. Just like when we have a constant and a variable, we can combine the variables, the constants can't be combined. Okay, any questions on adding? Oh, so 6 minus 30 is negative 24 square root of 2, and then plus 20 is negative 4. Any other questions? Okay. All right, now we're going to multiply. So a couple thoughts on this. To multiply, what's inside does not have to be the same. Like before, to add, these had to be exactly the same, like the square root of 2 in order to add them. Here, the square roots, what's inside doesn't have to be the same, but what does have to be the same is that it's a square root. Like you can't multiply a square root times a cube root, but you can multiply a square root times a square root or a cube root times a cube root, and it doesn't matter what's inside. So what we could do then is just multiply those two together, and since they're both under a square root, we'll just put them both under a square root. So square root of 7 times square root of 10 is square root of 70. But then you would have to make sure it's simplified. So I'm kind of showing you the long way if you go straight to multiplying, because now we have to make sure it's simplified. What could we break it down to? Okay, so 7 times 10, and what's 10 going to break down to? Okay, so did you notice that when we were checking it, didn't we go right back to where we started, 7 times 10? And so that was kind of a waste, right? We multiplied them together to get 70, then we broke them right back down to 7 times 10 and then kept going. So what I would do instead of multiplying them first, I would just put them all together and break them apart as we go. So we will put a big square root. The 7 can't be broken down, so that'll stay there. But the 10, let's just break it down now. Rather than put them together to make them bigger, then turn around and make them smaller, let's just break them apart now to check everything. And you know what? You could do that in your head. You know, you could just think in your head, okay, 7 can't be broken down. 10 breaks down to 2 times 5. Is there anything we can circle 2 of? No. So that means that we will just multiply them. 7 times 2 times 5. Or 7 times 10. So you could check that in your head, you know, like break 10 down in your head, 2 times 5, you can see there's not going to be 2 things to circle. Okay, any questions on that? All right, so any, yes.
Right, the answer that is.
Yeah. Well, yeah, so like you can, so instead of breaking this to 70 and then breaking it back down and to the prime factoring tree and going right back to this, it's easier just to break down if it can be. But again, you can do this part right here in your head. Like you can just think, okay, 10 breaks down to 2 times 5. Then I know I don't have anything that I have 2 of. that I can circle. So then that tells me I can't break these, these won't be able to be simplified. So then you could go straight to multiplying them, or you can break them down on paper, you know? Yeah. For number 2, we would multiply. So you can't ever multiply the coefficient by the radical. It just has to stay there separate like this. But we can multiply a coefficient times a coefficient. So what's -2 times 3? -6. And then again, like if we hadn't just done square root of 7 times square root of 10, I would have done, in my head, I would have done, okay, 7 times, and then 10 breaks down to 2 times 5. I would have done that in my head and realized, okay, it can't be simplified. So I'm just going to multiply 7 times 10. So just -6 square root of 70. Does that make sense? We multiplied, thank you. We multiplied the square root of 10 times the square root of 7. All right, what about number 3? Okay. So here's the shortcut. Let's try that again. What if I had square root of 5 times square root of 5? That would be square root of what? And what is square root of 25? So do you see the shortcut? If ever you multiply a radical times itself, the shortcut answer is it's the number inside. So if we ever have square root of 5 times square root of 5, the answer will be 5. So what's square root of 2 times square root of 2? 2, right? Shortcut, right? Square root of 12, square root of 10 times square root of 10. Well, no, I don't want to do that one. Well, we could do that one. That's fine. Square root of, I'll pick a different one. Square root of 5, I already did that. Square root of 6 times square root of 6. 6, because it's square root of 36. Some people say 36. It's square root of 36, which is 6. So shortcut, a radical times itself is the number inside, is the answer. Yes. Yeah. Any radical times itself is the answer is the number inside. Okay. So what do you think for number 4? Yeah. Yeah, so we can multiply the 2 times 2, right? What's 2 times 2? 4. And then square root of 7 times square root of 7. Square root of 7 times square root of 7 is? No, it's not 49. It's square root of 49, which is 7. So remember, a radical times itself is the number inside, right? And that's a common mistake when I say, what's the square root of a number times the square root of a number? Like square root of 7 times square root of 7 is, as people say, 49, but it's square root of 49, but that is back to 7. So 2 times 2 wasn't in the radical. So we really did do 2 times 2, which is 4, but don't do 7 times 7 and put times 49 because it's square root of 49, which is 7. So those end up just being 7, right? 2 times 2 is 4, but square root of 7 times square root of 7 is 7, which is 28. Sure. Yeah, definitely. Please do. I'm just going to make up another one similar to that real quick. So what if we had 3 square root of 5 times 3 square root of 5? That's part of it. Okay, so no, I mean, you're kind of thinking the right things, but got a little lost. Yeah, so no. 3 times 3 is 9. Square root of 5 times square root of 5 is it's square root of 25, which is 5. Yeah, so 3 times 3 is 9. Square root of 5 times square root of 5 is not 25, it's square root of 25, but shortcut is it's 5, right? 3 times 3 is 9. Square root of 5 times square root of 5 is 5. So 9 times 5 is 45. You get that? Okay. So you have to watch out whether it's in the radical or not. Okay. All right. So distribute. Square root of 3 times square root of 2. So just so you don't have to worry later, do I break it back down? Let's just see. Can 3 be broken down? Like if we're putting these together, can 3 be broken down any further? Can 2? No. So if I put those together just like that, and I wouldn't do this, but I would do it in my head, 3 times 2, right? But there's no 2 things to circle. So I know it's just going to be square root of 6. So this step here, I would have just done in my head, like, no, that can't be simplified, you know, minus square root of 3 times square root of 5. Well, I can put those together. And again, this part you can just do in your head. 3 can't be broken down any further. 5 can't be broken down any further. And there's no 2 things to circle. That's how I could simplify. So I just multiply then 3 times 5. Okay. What else now? Yes. What's that? You're done, you're saying? So we're done? By doing what? But can we? But is this multiply? But we know it would factor to be 3 times 5, right? Because it came from that. Why is that it? And what's the rule for adding and subtracting? Yeah, they have to be like terms, right? Remember up here at the top? That's why we did this, right? To make them like terms so we could add them. And up here, like when we added these and they were like terms, but if they're not like terms, then we can't add them. These don't have the same radicals. They're not like terms. This is like x minus y. Yeah, we just simplified. Yeah, that's all we can do. You have to remember the rules, adding and subtracting, they have to be like terms, and like terms for radicals mean the radicals have to be exactly the same. All right. Square root of 6 times square root of 5. If you jump right to it, you would say square root of 30, but then you might think that's pretty big. I bet that could be broken down. But then you go backwards and break it back down to 5 times 6, right? Which is where we came from. So again, the shortcut to that is imagine, just even in your head, 6 would break down to what? Yeah, 2 times 3. If I had 2 times 3 times 5, is there going to be any 2 things I can circle? No. So again, this is, I wouldn't necessarily write it, but you can. But so instead of going 6 times 5 and getting 30 and then breaking it back down to check to see if it can be simplified, just break down as you're putting it in. So square root of 6 is 2 times 3, and we're going to multiply that times 5 minus, and then we can see though that nothing can be circled. So it is just going to be square root of 30. Now, what's different about this distributing back here? Okay, that and what else? What? Right, like these were two radicals, so I could put them together under a radical. These are not, so you can't do 6 times 3 and get 18 or square root of 18 because this is a radical, this is not. So how do you think we write this? Yeah, they can't be put together as far as actually multiplied together. That fly up here. So yeah, this just becomes the coefficient. This is like x times -3, same idea. It would be -3x. A radical is kind of like a variable. So this one, there's no two things to circle. So square root of 30 minus 3 square root of 6. Both the square root of 6 and the square root of 30 are all simplified, right? We checked them. Nothing to circle here. 6 is 2 times 3. Nothing to circle there, 2 of. So now what? Yeah, they're not like terms and we can't, they're both simplified. You definitely check to, make sure they're simplified because sometimes they can become like terms when you simplify them. Jasmine. No, no, open your eyes, follow along, take notes. What do you think about number 7? Okay, FOIL. So go ahead and FOIL, try that. Do we do what? If you're going to do it that way, yeah, because it is square root of 6. It's not just 6 times 6. It's square root of 6 times square root of 6. Give you enough time if we start? What'd you get when you did first times first? -28. Everybody good with that? Okay, outside. Yeah, so we can't say 42 because the 7 is not in the radical and the square root of 6 is. So remember, it's kind of like a coefficient and a variable. So what? You said, I thought you asked about the square root of 6 times square root of 6. Yes, but when we do our outside, 7 times square root of 6, they're not in the the 7's not square root of 7. If it was square root of 7, then we could say square root of 42. But we just have to say 7 square root of 6 because the 7 is not in the radical. Okay, yeah, like 7x, like, yeah, as if this had been an x. Radicals are very much like variables. As far as like terms, and when you distribute, you would just say 7x. It's kind of like that idea. Well, no, we can't multiply 6 and 4 because they're not both in the radical. So it's just -4 square root of 6. Like here, we didn't do 7 square root of 42, right? We didn't multiply 7 and 6. We don't multiply here either. So we just say -4 square root of 6. Is everybody with me? Okay. Last plus what's square root of 6 times square root of 6. Not 36, but so like this, Lisa, 36? Yes, square root of 36, right? This equals square root of 36, which equals 6, right? So you can put, if you want to on your first step, if you want to put the step of square root of 36, but remember, radical times itself is the number inside. So I would skip putting square root of 36 and I would go straight to 6, you know. But oops, it's not letting me erase that. Let me try again. Okay, so let me just write up here. So we have square root of 6 times square root of 6, which equals square root of 36, which equals 6. So remember, radical times itself is the number inside. But if you are going to say 36, you have to say square root of 36. Okay, now which ones are like terms? Okay, these two. So what is -28 plus 6? Okay. And these two are like terms, right? What do we get there? And what sign? Yeah, 7 minus 4 is 3, square root of 6, right? Just like if you had x's, if you had a 7x minus a 4x, it would be 3x. Square root's kind of like a variable. Because when you add and subtract like terms, you don't change the variable. Remember back up here? We didn't change this to square root of 6, right? We just like here, we don't change x's. We just say 5. We add the coefficients, but the radical stays the same, just like terms. Okay, so yeah, remember when you multiply, it could change the radical, but when you add the coefficients, but the radical doesn't change. Can we go any further? No, because those aren't like terms. We have a constant and then we have a variable. I mean a radical. Okay, you want to try number 8 by yourselves? Go for it though. Okay. Maybe we could write each one of these out. Just, I mean, you don't have to, but I think I will just to catch everybody who's struggling a little bit. So first times first is going to be 5 times -1, right? Okay. I'm going to do each, then what's that going to be? -5. Did everybody get the first one? Okay. Okay. Now outside, what sign is it going to be? Yeah, because positive times negative will be negative. We're going to multiply 5 times 7. Well, maybe I'll write it this way just to help you out here. So it's a positive 5, so I'll put a plus. But we're going to multiply it by -7 square root of 3, right? So what is 5 times -7 square root of 3? Yeah, -35 square root of 3. So this 5 can be multiplied by the 7 because they're both out of the radical, right? So 5 times -7 is -35 square root of 3. It's as if this was a -7x. We would do 5 times -7 and then add the x. Okay. Inside is +2 square root of 3 times -1, which would just be what? Yeah. And then last times last is, I'm going to run out of room. It's going to be right here. +2 square root of 3 times -7 square root of 3. Let's go down here and do it. So we have 2 square root of 3 times -7 square root of 3. What can we multiply together? Okay, 2 times -7 is? Okay, -14. It'll stay square root of 3, which is? Yes. Okay, so 2 times -7 is -14. Square root, I don't know where to put this. Square root of 3 times square root of 3 is square root of 9, which is 3. Remember, a radical times itself? Yes. Yeah. So I'm just going to add that here right now. So -14 times 3. So that was, so again, 2 times -7 gave us the -14. Square root of 3 times square root of 3 is 3. Everybody get that? No? Okay. Let me do it. If the radicals are both the same, well, then the answer is the number inside, though, not the radical of that. Yes, square root of 3 times square root of 3 is just 3. Right, because it's square root of 16, which is 4. Well, just if you did square root of 4 times square root of 4, you would get square root of 4 times 4, which is 16, and square root of 16 is just 4. Square root of 7 times square root of 7 is square root of 49, which is just 7. Because we multiply them together and then turn around and take it back out. Okay, so Charlie, back to on just that last term. Okay. Okay, so we have this, right? We have 2 square root of 3 times -7 square root of 3, right? Okay, so that's just from this last times last. Do you get that? Not quite, because, okay, so let's put the 2 and the -7 together. So 2 times -7 times square root of 3 times square root of 3. I'm just rearranging. Do you see that? So I just put these two together and I put these two together. Does that make sense? Yes, so this is negative 14. But what is square root of 3 times square root of 3? 3 times 3? And square root of 9 is? Yeah, remember a radical times itself is the number inside. But you know what, if you want to, if you guys, if that's too weird, just go ahead and do the each step. Square root of 3 times square root of 3 is square root of 9. On your next step, change that to 3.
That is.
Yeah, but if you want to do this, just put square root of 9. So 2 times negative 7 is negative 14. Square root of 3 times square root of 3 is square root of 9. The one thing I don't want people to do is say 9. A lot of people say square root of 3 times square root of 3 is 9. It's not, it's square root of 9. Yeah. Yeah. Okay. So negative 5 out here. These are like terms, right? So what is negative 35 square root of 3 minus 2 square root of 3? Okay. Negative 35 and negative 2 is negative 37. The radical doesn't change. Okay. We just did these two for now, right? And then back here we have minus 14 times square root of 9 is 3, right? I just kind of took an extra step there. So 14 times 3 back there is what? Okay, minus 42. And these two are like terms now, right? Negative 5 and negative 42. Yeah. Square root of 9. So up here when we did 2 square root of 3 times negative 7 square root of 3. So here's 2 square root of 3 times negative 7 square root of 3. So 2 times negative 7 is negative 14, right? You see that, Giselle? And then square root of 3 times square root of 3 is square root of 9, right? This 3? Because do you see that? Because square root of 9 is 3. Yeah. This? No, that was from the F.
Multiply 5 against 7.
Oh, here?
7.
Yeah. This was outside. Yeah.
You could do that?
Yeah. It's just like this. If we had x plus 5, I'm just making this up, times x minus 2, we can do x times x, or we can do a variable times a constant, right? It's the same idea. A radical is like a variable. We could have even done, so like if we multiply the radical times itself, or we can multiply the radical, I'm just using a variable to show you, times a constant.
I thought you did. I thought you already full and you got 5. Negative 7. I did. I got 5 by itself. Then you did 5 by itself. It's 7. So it's being done in the actual step. It's just part of how to multiply.
Yeah, I just wrote each step because this is difficult. So 5 times negative 1, I just wrote that here. Yeah. Then outside, I just wrote 5 times negative 7 square root of 3. And then that gave us negative 35 square root of 3, right?
I just assumed it. Where you couldn't.
No, it's just like a coefficient. Like if this had been 5 times negative 7x, I would have said negative 35x, right? Yeah, imagine the radicals like a variable, same rules. And then I multiplied inside, which is 2 square root of 3 times negative 1. I just ran out of room here. So this It was first, outside, inside, and this was last down here. I just ran out of room. Are there any other questions along these steps? Giselle, are you good? Okay. And then we're,
Can I see a picture?
yeah, let's finish it though real quick. What's -5 times -42? I mean, not times, minus. Oops. -47 minus 37 square root of 3. Do we? Are they like terms though? Right, because imagine this, Lisa. So imagine like the radical is a variable, -47 minus 37x. Would I be able to put those together? No, they're not like terms. Remember, I can add two things that if they both have square root of 3, like up here, right? I was able to put these two together because they were like terms, but these two are not. This is a constant and this one has a radical. Does that make sense? Right. I know. Just always remember like terms. We can only add like terms. Yeah. Oh. When we're done, I'll give you guys another one to practice because that seems shaky for some of you. I'll sit down with you, Charlie. We can do it together. We'll do it together. And I'll do another one when we're done with these three. I'll do one more and then we can also, I can go back with you and look at this together with you. Okay. I thought this would be easy for you guys because it's just foiling, but the radical's kind of screwing you up, huh? Well, they are though. They're the same rules as before. You can multiply a variable times a constant, but to add, they have to be like terms. It's the same rules. Yeah, you can multiply things outside the radical together, but you can't multiply something from outside to something inside. So you can multiply coefficient times coefficient or radical times radical, but not coefficient times radical. Like those just stay like that. Anybody recognize these? Conjugates. So it will be difference of squares, right? But we can FOIL anyway, but we know outside and inside are going to cancel out because they're conjugates. So what is 6 times 6? Okay, 6 times 6 is 36. What is 6 times negative square root of 11? Yeah, negative 6 square root of 11, right? Negative 6 square root of 11. Okay. Inside square root of 11 times 6. Yeah, we can't put those together. If it was square root of 6 times square root of 11, we could say square root of 66 and multiply them. But when one's outside and one's inside, they stay that way. So plus 6 square root of 11. Now, last times last, square root of 11 times negative square root of 11. Yeah, but first let's go back to not the square root 11s. What is square root of 11 times negative square root of 11? We know it's negative. Yeah, because what's square root of 11 times square root of 11? square root of, not just 121, square root of 121, square root of 121 is 11. So remember, a radical times itself is the number inside. So minus 11. Everybody good on that? Okay. Just minus. A square root of 11 times negative square root of 11? Because what's square root of 11 times square root of 11? Okay, Duncan, thanks. Yeah, it's negative square root of 121. Yeah, they're not adding, yeah, we're not subtracting. Oh, yeah, it's not square root of 11 minus square root of 11. Yeah, yes.
So I assume I'm on L now. Am I- So L, obviously, is that, I think it's like 121 is what
Yeah,
11 and 11 would make, but break it back down to 11, but that negative carries.
yeah, because positive times negative, just like here, you know, we've got a positive times a negative, so we know it's going to be a minus. Yeah, that's just a sign in front. And then square root of 11 times square root of 11 is just 11. Now we have like terms, right? These are like terms. And these are like terms. 36 minus 11. 25. What happens to our middle terms? They cancel because one's negative, one's positive, right? And here's something you'll get to know. Conjugates with radicals always FOIL all the way down to just one. Oops, where'd that? All the way down to just one number. Conjugates always FOIL down to one number when there's radicals. Because a radical times itself, the radical's gone. Middle terms cancel out. Those are the ones that still have the radical, and they'll always cancel out.
That one was so. That one was.
Okay. All right. So something squared means what? What, number 10? What? Not conjugates though, because this squared means same thing twice. Conjugates are one with a plus, one with a minus. So what do we write? What does, yes, but we don't write conjugates, right? Because it's same thing twice. Yeah. Duncan, are you working on this? Okay. So I would say write every step out then. Okay, so first times first, I wrote them out. And this is what I do. If you guys are kind of shaky on this, literally write out what you're multiplying. Square root of 2 times square root of 2. Yeah, it's square root of 4, but you can skip that step and go straight to 2. Are you getting that now? So 2. Outside was square root of 2 times 5. I wrote it right here. Yeah, can't put them together because they're not both in the radicals. So that's just plus 5 square root of 2 plus inside. Yeah, another 5 square root of 2 plus last times last. 25, 5 times 5. Yeah, because the 5 times 5, oops, gosh darn it. The 5 times 5 was not a radical. It wasn't square root of 5 times square root of 5. Yes. All right. So this is a like term with this. So we get 27. These are like terms. Do they cancel out? No. So we get, well, because they're both positives. Remember, one needs to be negative and one positive to cancel out. So it's a positive 10, I mean, positive 5 plus 5, that. So what are we going to get? Yeah, 10 square root of 2, right? We add the 5 plus 5 and the radical stays the same. (27) plus 10 square root of 2. Are there any questions about either of those, any of those steps? Square root of 2 times square root of 2 was just 2, right? Square root of 2 times 5, can't put those in together, so we just say 5 square root of 2, another 5 square root of 2 plus 25. These two are like terms, they don't cancel out. So we add them together. And when you add like terms, the variable doesn't, the radical doesn't change. 2 plus 25. Those are like terms. Everybody good? Okay. All right. Number 11, I mean, it's the same concept as number 10, right? It's a binomial squared. The only difference here is both are radicals. So see what you can do with that. Yeah. Uh, where? This -3, negative square root of 3 times like the 10. Yeah, just what's negative times a positive. Yeah. Okay. First times first, I wrote it down here. First times first means square root of 10 times square root of 10. What is that? It's not 100. It's square root of 100, which is 10, right? So don't say 100, square root of 100, which is 10, right? Any radical times itself is the number inside. So we have 10. All right, then we did outside. I wrote it right here. Oop, right here. Outside was positive square root of 10 times net. Oops, I didn't get my negative in there. Wait, which one are you doing? First times first? Radical? But it's not. Because square root of 10 times square root of 10 is square root of 10 times 10 is 100, right? And the square root of 100 is 10. Yeah, so it's not square root of 10 because it's square root of 10 times another square root of 10. There's no way it would still be square root of 10, right? Okay, and then when we do outside, we have square root of 10 times square root of 3. What would 10 break down to? 2 times 5, and 3 is already broken down. So can these be simplified if we multiply them together? No, because 2 times 5 and a 3, there's no two things to cross off, right? So we know we can just multiply these two together. So what are we going to get? Yep. They're both radicals, so we get to put them together. If one was a coefficient, we'd have to put it in front. But these are both square roots. So square root of 10 times square root of 3 is square root of 30. So we have minus square root of 30. Can't break down. We already checked it because that's 10 times 3 and 10 breaks down to 2 times 5. Nothing we can circle. Okay. Outside is negative. Wait, where am I? I lost my thoughts. Negative square root of 3 times 10 is what? Negative, not 30, square root 30. I'm going to be a stickler about that. Minus square root of 30. And then last times last. So first of all, negative times negative. Okay, plus, so positive. Yeah, what's square root of 3 times square root of 3? No, square root of 9. If you're going to multiply the numbers, you've got to say square root of 9, which then is 3. Huh? I know, I heard you. I was correcting other people. What? Because square root of 10 times square root of 10 is square root of 100, which is 10. Square root of 100 is not square root of 10, it's just 10. So remember, a radical times itself is the number taken out of the radical, always. See here, square root of 3 times square root of 3 was square root of 9, not 9, square root of 9, but square root of 9 is just 3. So we multiply a radical times itself. The answer is the number that's inside, but drop the radical. Yeah, I do feel like I've said a lot, but it's okay. You're sweet, Lisa. Okay, oops, any other questions on that? Okay, so now what? I didn't leave myself room to finish this. Okay, so a 10 and a plus 3, right? 13. What about here? This one's that tricky one I mentioned at the very beginning. People get this wrong all the time. Minus 2. Yes. It's not square root of 60, right? We do not add inside. Remember, when they're like terms, you add the coefficients. Each of these is 1 technically. So a -1 and a -1 is -2 square root of 30. So many people say square root of 60 on that, or weird things. But when you add or subtract, the radical stays the same. You add the coefficients.
I didn't know. I wanted to do that, but I was like, okay.
Way.
Oh, okay.
You rock.
Flexible.
So yeah, just like if you saw a negative x, we always, if there's no number in front of an x, it's a 1. Same with a radical. You got to just always replace in your head, replace a radical with an x and think yourself through it. It's the same rules. Like if we had a negative x and another negative x, we have -1x, -1x, we have -2x. It's the same concept. Yeah. Well, I'll tell you what. I know I said to give you another one, but I have a practice worksheet. So let's just work on this in almost half an hour. I bet you can get it done. And it'll be time to, and practice together. Please get in groups because some people, I know some of you get it, but some don't, so they could really use your help. Let me do this real quick though.
Well, then, never mind.
So homework for the weekend. You guys are lucky you're not in the late start class. That one's grueling. 8.4. So 8.4 practice worksheet, I think you'll get that done today in class. And if you do, you can turn it into me if you want. So this, I think you'll get done. So 8.4 homework, and we do have a quiz on Monday over 8.1 to 8.4. So here's a practice quiz in My Open Math as well. So the two My Open Math assignments are the 8.4 and then the practice quiz. And the quiz is taken right out of that practice quiz as always. So just do this until you really feel good about it. And then any test corrections that you have. Okay, so I think you'll be able to get this practice worksheet.
There's now. Oh. Yeah, it says it. Somebody to work with.